Hello, and welcome to another episode of Kopel's Law and Liberty News. I'm Dave Kopel, Research Director for the Independence Institute in Denver, Colorado, and this program is brought to you by Independence Institute Television. Today we've got a great interview with the author of this major new book, Ghost Guns: Hobbyists, Hackers, and the Homemade Weapons Revolution. This is all about 3D printing and how it's going to change not only gun control, but perhaps many other things. And I will, in the interest of full disclosure, tell you that this book started out as a PhD thesis at the University of Denver, and I was on one of the faculty advisors for that thesis. So I've seen it from when it was just a baby and when it was only a proposal, and it's gone through many stages, and now it is a really great book, interesting and accessible to experts and non-experts alike. And with all the controversies that go on over the gun control issue these days, pro and con, this book, again, let's show it again, Ghost Guns, may be one of the most important ever written, because it's not about the things that are the topics du jour, but how the manufacture of firearms is changing drastically even as we speak. So I'd say welcome to our author, Mark Tallman. Mark, you want to give the audience a little bit of background about yourself? Like, where are you and where do you teach now?
Sure. I formerly, as you alluded to, started on this topic several years ago as a PhD student at University of Denver. And you were kindly one of the sort of quasi-team of rivals, I guess, people who, academic advisors on that project who were open-minded enough to think that this was going to be a phenomenon of considerable import into the future, not just in the gun space, but beyond that as well, in the tech space and information space. So, regardless of the kind of angles from which different people who were kind enough to advise me on that project come at the conventional mainstream conversation on guns, I felt that the advising I did receive for that was very good and open-minded. I then went on to teach at Colorado State University, Pueblo, teaching Homeland Security, and now I've recently joined the faculty at the Massachusetts Maritime Academy, teaching Homeland Security and Emergency Management. Super.
Are you still doing more research on this topic?
Absolutely. In fact, just earlier today, I was looking through some feedback that's been sent to me by some folks who are in the DIY firearm space and digital firearms development. I'm already planning to update this book and new publications around some of the innovation that's happening in this space, which is really faster, I think, than almost everybody's really been able to keep up with.
So before we start talking about today's innovations, let's give the viewers some background about homemade guns in general. You know, when most people think about buying guns, they think about, I'll buy a pistol from Smith & Wesson that's made in a factory in Springfield, Massachusetts. It's mass produced and in very high quality, and then that goes out to wholesalers and retailers and ultimately to the consumers. And has it always been like that for gun manufacture?
It has not. And the current kind of paradigm, the regulatory assumptions that we make in how we govern or try to govern the firearms space in America and in other nations too, is based on industrial era assumptions about how guns are made. The sort of what I would associate with a supply side control paradigm, the idea that we're going to control the social outcomes of guns or the usage of guns at the ground level by controlling the supply chain and retail layer of that delivery chain. That is based on industrial era assumptions that were not always the case. Firearms have been around for 1,000 years. It's a very mature technology that's now kind of moving into new, interesting space in terms of design and fabrication. But for a lot of the history of firearms, they were not very effectively controlled from the supply side. And they kind of moved beyond state monopoly within a couple hundred years of being widely developed on the battlefield, for example, in armed conflict. Eventually, it did demonopolize and diffuse out and had major historical consequences for the way governance works.
So fill us in a little bit on that. So you're saying there was a time, sometime before the Smith & Wesson factory was founded in the 1850s, when people might be making guns in their home or their cabin or whatever?
Sure. Yeah.
Elaborate on that.
Right. Well, it's more or less an artisanal paradigm until you reach the point of industrialization in the early 1800s, approximately. A little bit of overlap. But the paradigm of production was artisanal. It was artisanal tools and methods, and even for a long time, centuries, pre-scientific knowledge about the underlying physics. And yet still there was considerable innovation in the design and building of firearms, even before you had anything like the modern factory environment. So with the rise of that modern factory environment, you get a new idea that you can control guns more effectively because now guns are only made in factories. And now the latest stage of development, I think, in the technology is starting to question that regulatory paradigm that came with industrialization.
So pre-industrialization, you might have had a friend who was really skilled blacksmith, and you just go to him and ask him to make you a gun, and he could?
Yeah. It was not uncommon in many countries, particularly in Europe, where it became somewhat decentralized relatively early, and there was more free trade and movement and so on, more regimes that had difficulty trying to really clamp down on any particular style of gun making or design or that kind of thing. It was just harder to control in the European and then colonial context.
Okay. Well, let's talk about that, some of the colonial and post-colonial. We're going to talk in this program about new technologies, 3D printing especially, and all the variants of that. But to what extent, let's put aside all that, and let's talk about folks who don't have 3D printers, like, say, some tribes people in West Africa. Mm-hmm. Have they been involved in homemade manufacturing of guns?
Absolutely. From early days of colonialism, you have local populations who oftentimes were themselves being colonized and even oppressed, who reverse engineered what they called trade guns, and oftentimes in very clever ways managed to emulate or re-engineer some of the products that had been brought by European colonial and trade explorers and things like that. So that kind of innovation at the ground level has been with us, I think, and just part of human ingenuity from the start of firearms becoming a widely known product.
So let's say we're talking the late 1800s or the early 1900s in Africa or other colonized areas. These are places where the locals don't have access to a lot of high technology of the time, lathes and all machine shop tools and things like that. Yeah. How could they possibly manufacture a firearm without those kinds of tools?
Well, I think the question kind of harkens back to what are those technical prerequisites that you need to make the most basic and functional types of firearms? And the answer is the most basic kind of artisanal tools. And so, even today in parts of Africa, parts of Asia, where, people are not wealthy, they may live in poverty, but they want firearms. There are some extremely simple artisanal methods that people use with just hand tools, electric drills, electric lathes, and routers, and so forth. Really simple stuff in terms of, garage level tools. You don't need a specific gunsmithing kind of modern gunsmithing environment. It's being done. And it's been done since early stages of colonialism, and it continues to kind of evolve today. And I think an important aspect of this that it needs to be acknowledged, we often talk about this phenomenon of DIY firearms and all of its new kind of implications, just in terms of emerging technologies, digital fabrication, and 3D printing. But it's really important, I think, from a a governance and regulatory perspective for that conventional, how do we deal with guns conversation that we have in this and other countries, to understand that guns are 1,000-year-old technology. Simple versions of that can be reproduced, emulated, improved with even the simplest tools and methods as well.
So, and I guess if you're saying it started with early colonialism, that would mean that you don't necessarily even need to have electricity or electric tools to do it.
No, not at the simplest level. Now, I would say that there is a skill trade-off as well, because if you want to make anything approaching a modern firearm that would emulate, a conventional industrial product today, to reach that kind of design quality and fabrication quality takes an awful lot of artisanal skill with very, very simple tools. On the other hand, you make a trade-off in terms of skill, or at least you sort of switch it over to newer and emerging types of skill sets that are increasingly applicable when you adopt newer technologies to do so as well.
So in these primitive tools, say whatever people were making in Ghana in 1830, I'd presume those were mainly single-shot black powder guns.
Yes, stuff like that.
And so they couldn't, say, manufacture what was the state-of-the-art at the time, like a Colt 6-shot revolver.
I'm not aware of that at that point in the timeline in the colonial history. Now, some of that could have been going on, and I'm just not aware of it. But what I can say is that from approximately the early 20th century, you have an increasing diffusion of even those kind of mid-range tools like lathes, where you have local populations working with, relatively simple or intermediate level tools, able to reproduce things like, revolvers, starting to reproduce things like semi-automatic pistols and so on. And that became actually sort of jump-started or continued and improved by a number of kind of militias and anti-colonial movements and things of that nature. So the DIY thing it reflected the technologies available to people at that time, and of course it reflected the social issues of why do people want guns and what are their options to get them.
Well, why do people want guns? For example, let's continue in sort of the West African or the colonized peoples. What do they want guns for?
There are certain universals, I think, to why people would want firearms. And most of them are reflected in the kind of legal gun culture that we have in the U.S. and legal gun cultures that are around the world. Guns can be a lot of fun, recreationally, hunting, and subsistence, pest control, things like that. And those are pretty strictly utilitarian needs that people have. In less developed nations, economically less wealthy nations, agrarian countries and cultures and so on, those are not, frivolous needs necessarily for those populations. And if they don't have access, then, that's human ingenuity. They're going to look for other ways.
So let's think about sort of the last several decades of the 20th century and then up to now. But again, not talking about the new technologies like 3D printing. In places like, say, Afghanistan or the Philippines, what's the sophistication of guns that people are making in garages or some other place at home?
Right. Now, that production model or that style of production has oftentimes been called by academics craft manufacture. And that is manufacture oftentimes in austere environments using relatively simple tools. And there are populations and cottage industries all around the world in various regions that produce and sometimes trade guns this way. Afghanistan being one of them, and so-called Khyber copies and so on. The Philippines, yes, have a significant cottage industry for this. And for the most part, a lot of that stuff is kind of low to mid-range technology. We're not talking about digital fabrication. We're not talking about any of the kind of fancy stuff that media tends to be following as part of this, quote unquote, ghost guns issue. A lot of it is kind of lower down in that industrial fabrication chain. And so you get a lot of skilled labor and semi-skilled labor, and people just working in workshops with a lot of hand tools and a little bit of electric tools, and producing more or less emulated knockoffs of mainstream products. So you get semi-automatic pistols. There's quite a lot of decent looking Makarovs and AK knockoffs that come out in Asia and Southeast Asia. And if you pull them apart, you look at the internals, you're going to see immediately that this is not the industrially produced version. But they're made to be appealing on the market. They're made to be functional and reliable enough for the purposes of consumers in those areas.
Okay, so tell the viewers first of all what a Makarov pistol is, okay. and then if you could elaborate a little bit on the difference of what's the difference between getting a factory Makarov versus a knockoff that somebody made in the Philippines.
Right, like a Makarov is a Russian-designed pistol, very popular. I would say just aesthetically, it's kind of similar to a Walther PPK, and I believe it's also blowback. So Makarovs have become kind of a popular knockoff or counterfeit type of firearm that craft producers have built around the world, simply because it's easy to emulate, and there's widespread knowledge of what they look like and how they work. So you have versions of knockoff Makarovs produced in Central Asia, as an example, or Southeast Asia, where if you look at it superficially, it looks really similar to the real deal. You pull it apart and you see that the actual fabrication process, the tolerances, the materials quality are not the same. Oftentimes they look quite different inside it, once they're disassembled. But they're made to look as close to the real deal as possible externally, sometimes even including false markings or knockoff markings and things like that.
So somebody makes one of these guns. Where do they get the ammunition to put in? Because it's my understanding that you can make black powder ammunition at home, but modern smokeless powder is something for which you really need a serious DuPont and Nemours chemistry factory.
Right. And in my research thus far, that seems to still be somewhat of an obstacle in terms of just the pure capability and diffusion of fabrication ability. There are still some technical obstacles to being able to do that, and I certainly wouldn't recommend people mess around without appropriate safety and skill sets with things like propellants. But the black powder issue, that's been kind of a reliable DIY workaround for certain types of firearms. Certainly it works best for shotguns, but shotguns have been, an expedient firearm that's very popular around the world for a lot of reasons. There are some people who have kind of experimented with sort of devolving, actually, in the technology chain. Instead of using the most modern propellants, which, as you said correctly, are relatively difficult to produce safely in any kind of DIY environment, you can devolve to black powder, which is fairly easy to make on a DIY basis. And there are people who kind of scrounge or find DIY ways to try to produce primers, which are probably the hardest part to emulate without industrial technology in an industrial factory environment. But in terms of the regulatory paradigm, let's say, we're already in a situation where, if there are concerns about trying to control firearms from the supply side, and let's say we give up on the supply side paradigm, there's still the issue of ammunition and the fact that there are lots of ways to either reload ammunition or make kind of devolved, simpler propellants and simpler versions of them. And there are also people experimenting with ways to emulate the highest quality modern products for ammunition as well. So even ammunition, which is a relatively difficult kind of component of the firearm supply chain is still something that has been improvised many different ways over centuries, and is still something that people have a lot of space to experiment with.
So let's bring things. Well, let's keep them in the late 20th century. And again, we're going to get into all the swell stuff today, like the theory that you can buy a 3D printer and push a button and have a Glock 20 minutes later. But talk about the changes in machine tools and technology that started taking place, I guess, in the 50s with numerical control machine tools, and then about how those, well, let's start on those, and then we'll talk about how those diffused from the factory floor to the basement workshop.
Right. And yes, you mentioned numerical control, and that's really a key part of this kind of technology chain that has developed since approximately the 50s. So in the era of World War II, you have more and more interest within the mainstream defense industry in better targeting systems, better fabrication processes for all kinds of defense products and things like that. And in aviation, they come up with numerical control fabrication machines. So it imposes a much higher level of customization, programmability to fabrication tools, right? And of course, this very quickly, in the post-war environment, expands to all kinds of manufacturing and fabrication, had tons of really positive impacts in terms of mainstream industry. Over time, the numeric control becomes computer numeric control, digitized, which increases the kind of customizability and flexibility you can have in terms of programming what a tool can do. And so over several decades, you get fabrication tools that are basically pretty similar in terms of metal fabrication and things like that. It's doing similar things to what skilled artisans could do in the past, but it's increasing the customizability, the flexibility of that, and numeric control and computer numeric control tools, digital fabrication tools, increase the level of precision and customizability you can get with the same tool, as opposed to having an entire factory floor of a bunch of different tools, each tool, being analog. In the past, you'd have to have a whole floor, a whole, warehouse full of industrial level tools, some of them, bigger than a car, right, in order to have each one of those tools handle one part of the overall fabrication process, right? So this tool cuts this well here, this tool cuts this spot for the rail, and so on. Nowadays, with a digital fabrication tool, if you've got the skill and the materials and you know what you're doing, you can not only design with a great deal of flexibility, but you can manufacture a much wider spectrum of things and emulate the kind of precision that used to take a whole factory to make.
So let's just give a concrete example. So something familiar, the slide on a Colt 1911.
Mm-hmm.
What's the difference between how that was being made in 1912 versus how it would be manufactured, say, in 1990?
Mm-hmm. Well, in 1990, I imagine the mainstream manufacturers, it's more of, if we're talking about across the sort of 20th century, I think we're talking about incremental improvements to processes that were very similar at the beginning. So, by the early 1900s, you've got the whole basis for modern firearms manufacturing. So, modern stuff that's being produced in a factory environment is really not much different than anything that was being built in the factory environment in the late 1800s, as an example. All of those basics are there. Industrial manufacturing tools, lathes, increasingly now, CNC and digital metal fabrication. Those are things that have really been brought in post-war kind of technology environment with numeric control and computer numeric control. So digitization of those tools. But basically, the early 1900s or late 1800s version of producing that same kind of item, it would just require a lot more larger tools, oftentimes, and more skilled or semi-skilled labor to be part of the finishing process and so on. So nowadays, the mainstream manufacturers, they've got very precise processes, and the fabrication tools that they're using are increasingly multi-use, let me say. So as the technology gets better, you have tools that can do more of the fabrication functions in one actual tool, as opposed to needing an entire factory floor of 20 different tools to do 20 very slightly different fabrication functions to finish something like a slide.
Now let's talk about the average citizen. So he bought his Colt 1911 in 1911, and then in 1912 the slide broke, and he'd like to just make his own replacement slide at home. Mm-hmm. Tell us about the difference between what that guy's going to have to go through in 1912 to make the all-metal slide for the Colt 1911 pistol, which has lots of indentations and very precise grooves, things like that. And then let's say his great-great-grandson wants to make a new slide for that gun, and now it's 2012. What's the difference between what those two people can do at home?
Right. Well, I would say that the main difference is not really in the fundamental ability to do it. The main difference is the cost and difficulty of doing so. And the difference there is that let's say a semi-skilled or skilled maker, if you're replacing a slide in 1912, you're going to pay a lot more, adjusted for inflation, for fabrication tools that can help you do that. So, lathes, and particularly lathes, which are really central to this, were, adjusted for inflation, much more expensive in the early 1900s. Nowadays, with really a great deal of the economic result of globalization and modernization of the factory environment, you have actually a plenitude of the same kind of tools that were already available back then for a skilled person to try to do their own kind of gunsmithing. Those same tools are available, but they're better and they're cheaper than they used to be. So that's really the primary difference, I think.
So what would it cost if some guy said, I'd just like to build some regular guns, not involving plastic polymers or anything new, but just I'd like to build some all-metal guns for myself at home. How much does that fellow have to spend on his workshop?
I think it also depends on how much of the manufacturing process do they want to take on themselves in the workshop environment. So if you're talking about absolutely building everything from scratch, you're talking about a considerable amount of skills that you're going to need to develop. You're going to need metal lathe, clearly. You're going to want routers. You're going to want a whole bunch of hand tools and electrified shop tools. And you're going to want to, if you're working on wood furniture, you're going to want some carpentry skill and woodworking tools and things like that. Which is not to say there aren't extremely skilled artisanal makers that are building things from scratch using technology that was available hundreds of years ago and technology that's available today.
Sure. And just on the furniture point, I think you meant that in the sense of the wooden stock of a gun.
Right. If you've got wood stuff, then you're going to want some woodworking skill, of course, and some of those little gunsmithing higher skill things that people do, checkering and so on. That takes some skill, some real skill. But to just emulate, okay, all you need is a functional barrel, some kind of trigger mechanism and frame, and the thing goes bang and will shoot modern ammunition. If that's all you're after, then that can be done with a wide spectrum of tools and skill levels.
Okay. Is it legal to manufacture your own firearm in the United States?
It is, and of course, this is where a lot of the modern day political controversy comes into it. A lot of the discussion on quote unquote ghost guns has been really focused on that aspect of things. But at the federal level, I believe that it has been legal historically to make guns for the individual, as long as they're not for commerce. So as you probably know, the basic regulatory paradigm at the federal level for firearms regulation in the United States has always been much more focused on commercial activity than on personal gun making. And so there's always been space in the United States for personal gunsmithing, as far as I can tell in my research, and as far as anybody else I've spoken with has been able to find. So the main kind of, if you want to say choke point or something to that, is where is that interface to commercialization, commercial activity, and at what point do we have definitions that would kick that personal gun making into the commercial regulatory paradigm, and that, of course, is where a lot of the controversy kind of arises today in the discussion.
So far we've been talking about all metal stuff. The people using in 2012 really the same kind of machine tools that existed a century before, except now the machine tools they're better, more precise, they're more affordable, but it's really still the same kind of fundamental manufacturing that was going on not only the early 20th century, but even in the last several decades of the 19th century. What is changing about that? What's now start telling us about plastic production and those kinds of things.
Okay, well, I think one of the really fundamental kind of trend lines in the background of this whole issue that really needs to be, I think, prominent in any kind of intelligent discussion we're going to have going forward about it, is that the open source revolution is developing and in some ways accelerating. And by open source revolution, that was a term that was coined in the tech sector and software. The idea that there are technology and software architectures that any kind of user, from professional engineers to just any hobbyist, can go into that software, go into that electronic device, figure out how it works, find new ways to mash up consumer grade technologies in these endlessly creative ways. And to combine those ultimately in the gun space, what I think is a neo-artisanal mode of production, which takes all of that accumulated knowledge and all of that accumulated fabrication technique and technologies that came out of the industrial era, and now combining that in a much more open kind of space for experimentation. And so, when it comes to tools that are now available to average, DIYers, you've got digital fabrication, right? Consumer grade digital tools that give you that level of flexibility and customizability that used to require either an extraordinary amount of artisanal skill or an entire factory environment to try to do. And, naturally, DIY gun makers were going to be early adopters to this because that's just one of the areas where this technology is so clearly applicable.
Fill us in a little bit more on that. I think when I think of open source, I think of somebody wrote a computer program, and if you're running Microsoft Windows on your computer, it's not actually that easy to get down to the source code and see exactly how the program operates. But when somebody writes an open source program, it is like that, and if you want to put in some new command lines in the program that runs on your computer, you can. How does that apply to whatever people are doing with gun manufacturing?
Yeah, that's right. And yeah, there's kind of a weird connection here that probably a lot of people wouldn't think of immediately to things like right to repair. The idea that you can control a technology from the top down through control of the information underlying it. In the firearms space and a whole bunch of the tech space, not even having to do with firearms, a lot of innovation has been driven in the past few decades by this open source idea. The fact that if you don't want to necessarily copyright and monetize your idea, your design, your software, your tech that you're producing, then you can put it out there for the world, and any kind of designer or developer can examine that, see how it works, and potentially build on it or improve it and mash it up into some new product, right? And that has underlied a lot of the accelerating innovation that we've seen in the tech sector, and a lot of the success that led to the success of the tech sector itself. And now, it's just branching out into the firearm space in very interesting new ways. But it's all about customizability. You could say fungibility of designs and manufacturing capability, to the point where, now we have a digital firearms development space with thousands of people involved, who are approaching this engineering question of how do you make firearms on a DIY basis for personal use using, any number of tools that are available today.
So what you're talking about, open source, seems to apply not only to new things like 3D printing with plastics, but also just to, I guess, what are now the traditional computer numeric controlled lathe you can buy for your home workshop.
Oh yeah, yeah, and lots of commercial and licensed gunsmiths, of which there are, God knows, tens of thousands in the United States at least. I spoke to a number of them, in the course of research, and even mainstream gunsmiths are buying digital fabrication tools at this point because they're very useful. The customizability, the ability to, in some cases, let's say there are firearms where the replacement part supply chain is weak or non-existent. You want custom parts, custom repairs, and things like that. Increasingly, mainstream gunsmiths are learning to use these tools in order to do kind of custom applications like that. So it's not just open source developers who are using kind of digital fabrication tools. It's really had a lot of impacts across the board. But it is the digitization of that fabrication process, and the fact that so much of that space is open source and allows for people to trade ideas, that you get a lot of the innovation that's happened.
Well, it seems like great, say, if you own Grandpa's gun from the 1930s and that manufacturer's out of business, you're saying now your gunsmith might be able to fabricate the part that the metal piece inside the gun that's necessary to get it back to functioning, even though there's no commercial supply of that particular part.
Right. Yeah, that's going to be an increasingly common application, because what some people in the tech space say about digital fabrication as a technology is the main benefit of it is that it provides complexity for free, is the terminology they use. So you're talking about tools that are able to produce complex objects, and the primary prerequisite to being able to do that is to have the skill to design that object rather than own a factory that can make that object.
So now tell us about how we've been in an all metal and a little bit of wood world so far. How do plastics change this, and plastic printing?
Yeah, and of course, plastic, the new or unconventional materials, non-traditional materials in this space is one of the things that's generated controversy, mostly having to do with concerns about detectability of firearms. But plastic, is one of the most flexible kind of materials you can do. It's one of the reasons it was so widely popularized in industry to begin with. So nowadays with plastic printing, aka additive printing, and plastic's not the only material available, but it is still at the consumer level clearly the most common in consumer grade home printers. So
let's quickly tell the viewers the difference between additive and manufacturing versus subtractive.
Right. So the vast majority of manufacturing of any kind of item for thousands of years was subtractive in nature. It was a subtractive process where you have, some piece of raw material, and in order to fabricate that into the part that you want, you remove material from it. You subtract from the raw material to create the final part. New digital technologies, particularly those that work with plastics and certain other materials like carbon fiber, and there's stuff that can print in Kevlar, there's stuff that can print in silicone. Those are additive processes. And so there's no raw material that needs to be cut away. It is literally just adding layers of material until the part that you want is precisely formed.
So, for example, for let's say a receiver for a rifle, in a subtractive process, you buy a billet, this basic rectangle-shaped piece of metal, and you make the receiver by taking stuff out of it, by drilling holes in it, shaving off a side, things like that. Right. Whereas in the additive process, you tell your 3D printer, here's the shape I want you to make, and it adds one thin layer at a time in exactly that shape till you have the whole thing produced. Is that accurate?
Precisely.
Okay.
Yeah, that's exactly how it works.
All right. So plastics is now additive. Plastics has always been additive. I mean, even in 1967, if Dustin Hoffman had gone into the plastics field, he wouldn't have had anything with plastic billets that you shave off to the shape you want.
Right. And with regard to, industrial manufacture of plastic, there is waste. There's injection molding and all these kind of, industrial plastic processes. I'm no expert on how industry, applies plastic in mass production of items, but there is waste that occurs from that process because a lot of plastic manufacturing was not actually using these additive digital tools for a long time. It was molds and injection molding and things like that. But a modern digital additive tool, a plastic printer, can produce with that level of customization or precision. And if you've got good designs and you're skilled and you know how to configure the device and the any work pieces and so on, and if you set it up that way, there's very limited waste from that process. And it's one of the promising things about actually taking these tools and applying them more in mainstream industry because it does cut waste.
All right. So suppose I wanted to get into the plastic production hobby. What is a 3D printer going to cost a civilian, a regular citizen, not somebody who's got a factory?
Right. Well, it really runs, a pretty wide spectrum, just like all kinds of other, tools and devices in the tech space. So you can find, high quality, consumer grade, home grade kind of printers that'll print in common plastics for anything from, let's say, $3,000 down to literally $200. There's used ones that can be even cheaper than that. And one of the kind of more interesting and ostensibly provocative aspects of this is that you can build 3D printers as well, and you can build these tools as well. So part of the open source revolution is not just that, you can buy a 3D printer for less and less money over time to get the same capability. It's also that you can buy components and tools from which you can build a 3D printer, right? And that adds a whole other kind of level of complexity to the regulatory question around this.
So for the guy who's really trying to be hardcore DIY and says, not only do I want to build my own gun, I want to build my own printer that makes the gun. Mm-hmm. Can he really build that all himself, or will there be some components that he can't make and that he's got to buy from commercially, sort of like smokeless powder?
Right. Well, I mean, if you're starting from nothing, if you're, in a cave and you've got absolutely no modern technology and you've got no ability to buy any kind of, modern equipment or tools or precursor parts, then it's a real uphill battle to try to build a 3D printer. But the point of this being that there are all kinds of tools and all kinds of things you can build with those tools that are available to a knowledgeable person or a motivated person using commercial off-the-shelf parts that are essentially unregulated. And it's hard to imagine a regulatory regime that would be able to regulate the whole wide spectrum of ingredients that go into the tools, and then the tools that can then produce more things.
Right, and we're going to talk about the regulation in a little bit. We want to make sure that we give the viewers a good foundation in what's actually there. So let's say you buy a $2,000 3D printer.
Mm-hmm.
And let's say your technology skill level is, you can operate a fairly sophisticated camera for photography. You know how to uninstall or reinstall software on your your computer, but you're no hardcore techie guy. What can you do with that printer you just bought?
Mm-hmm. Well, you can manufacture items with a great deal of precision once you have a little bit of experience with it. Use in common plastics that can be handled by the kind of printers that you have, and you can make just about anything out of plastic. Any kind of plastic item you could make within the size that the printer is capable of. So there's bed sizes and things like that. So you're limited in terms of the size of something you can make, and you're limited in terms of the quality of materials and the kind of engineering you can do with plastic only. But really, part of the whole ingenuity and innovation of this open source revolution is the fact that if you're willing and motivated to learn skills and learn about how things are made, you can increasingly make any number of things in a wider spectrum of materials over time. So with plastic, would you like to talk about, let's say, specific kinds of firearms that you could make with kind of the lowest level consumer grade plastic tools?
And let's start on that just for our hypothetical consumers. The guy, first of all, says in this all plastic gun I might want to make, and we're going to talk about the regulations that apply on that, because the federal law would say you've got to have a little bit of metal, but we'll get to that. He wants to make a barrel out of plastic. Can you buy a printer that's going to have a 3-foot barrel, or that can make a 3-foot barrel?
No, those are not. That's not going to be commonly available, and you wouldn't want a plastic barrel anyway.
Okay.
So printers that can operate in that wide of a field and produce single objects without any seams on them, for example, right?
Yeah.
As a single piece.
Yeah.
Right. To produce things that are at that scale, larger like that, typically you're going to need the printers that are going to be higher up in the price scale. But there are all kinds of ways that people customize printers as well. People have made various types of digital fabrication tools using precursor components and software, open source software. So there's a lot of innovation in that space, and they're always kind of coming up with interesting new ways to apply the tools and the materials that are available. What could somebody build, with your typical, $200 to $500 consumer grade printer? You can build something like a handgun frame. You can build certain types of DIY designs that are optimized to be able to be made using only a plastic printer. For the most part, there have been technical obstacles and engineering obstacles to try to make those really excellent firearms, because most good firearms still have some metal in them, although there's still been innovation in that space as well.
Well, let's talk about the guy with the $200 printer or the one with the $3,000 printer. What kind of plastics? I mean, do they just melt down their old milk cartons, or what's the actual supply of the plastic for these kind of things?
Right, and there's different kind of levels of this, different materials. So there are really common household plastics, which is like PLA plastics. Those are the most common. They can even be recycled. There are kind of companion technologies that come with some printers, or that you can build yourself, or you can buy, that literally will extrude and recycle household plastics, turn them into pellets that you can then feed into a 3D printer that'll print in plastic. So there are household plastics for this. The engineering difficulties of trying to make that kind of plastic work in a modern firearm is not a small issue. because materials wise, plastics simply aren't as good as metal in emulating the kind of quality that you're going to have in commercial manufacturing.
So what are the types of household plastics specifically that could be feedstock for the plastic printer? Soda bottles or what?
Oh yeah, that kind of stuff. Yeah, and gallon jugs, soda bottles, other kinds of plastic pieces that you could just drop into an extruder machine, right? And if it's all the same kind of plastic, you can extrude that, and the machine will reform that into plastic like ingots, I guess,
Yeah.
plastic pieces, and you take those pellets and you put them in as a medium for printing new items. And so that is hailed, throughout the maker community as an important innovation, because part of the whole reason for doing this, and part of the great appeal of this in a new, decentralized manufacturing economy, is that it cuts down waste and it allows us to recycle and produce high quality items out of recycled things we don't need anymore. We make stuff out of plastic all the time. It's part of our economy. And as soon as you discard that, it lives for thousands of years, right? And uselessly as trash.
It's sort of like inspiring, like the Colors of the Wind song from the movie Pocahontas, about everything's connected and the cycle of nature. And now your milk carton doesn't have to end up in a landfill. So, but let's suppose the guy with our basement 3D printer, can he just buy the plastics? Maybe he doesn't drink enough milk to have his own natural supply.
Oh yeah, you can buy the plastics. You can buy various types of plastics that are media for the household printers. You can recycle certain kinds of plastic and do it that way. And there are kind of some newer ambitions within the 3D printing industries about making other kinds of materials that are potentially better for firearm engineering and engineering of all kinds of things beyond firearms, out of home, consumer grade plastic printers. So things like carbon fiber, things like PEEK, which is plastic that is permeated with like metal powders and things like that. Various kinds of plastic metal hybrid materials that are printable like plastic, but they're stronger than the household plastics that have been most common at the consumer level.
Okay, so suppose you had a regular firearm you'd bought in a store from the industrial process, and there was some part in it that broke. And you also had some friend who was pretty good with 3D printing. What kind of parts would you say can be printed with consumer grade plastic printers now that you would feel comfortable enough that this new piece, I don't know what, a spring or anything else, is going to be reliable enough?
Right. Well, personally, I wouldn't want to put, a printed household printed plastic part in a well-made commercial firearm that was already purchased legally and so on. It's almost like you're decreasing the quality of that item by putting in imposing a plastic part into it. But there are plenty of modern firearm parts that can be emulated or reproduced in plastic, and certainly with metal CNC. So there are things like springs. People have come up with ways to 3D print springs. You can 3D print any number of components to modern firearms in plastic. And as you know, starting approximately late 70s, early 80s, a number of firearm manufacturers sort of had a kind of plastics revolution in terms of the materials they were using. That's not necessarily to allude to the mythology of the undetectable Glock and things like that people were talking about in the 80s. They weren't really undetectable. They used detectable amounts of metal at all times.
Right.
But in terms of, more and more of firearms themselves from the commercial industries are made of synthetic materials anyway. And it's part of that natural kind of evolution of the industry. So now you have plastic frames. Right. You have sometimes plastic triggers and fire control components, plastic magazines and things like that. That's pretty well embedded in the mainstream industry at this point. So those kind of components certainly can be emulated with digital fabrication tools at the home gun maker level.
But I would imagine, say, right, as you said, Glock was one of the first companies, but now everybody almost makes, say, handguns that might have plastic frames, and likewise, a lot of rifles have more plastic in them, including in the stocks and elsewhere. Even though your plastic printer at home might be able to copy that shape, would the quality of the plastic be really as good as what Glock is using in its factory in Smyrna, Georgia?
That's interesting. So early on in the kind of evolution of this at the home DIYer kind of level, the printers, the resolutions, the plastics that were available at that time were more narrow. And now there's kind of more innovation in that space to try to engineer around the materials limitations of the plastics, right? And so now there are DIY developers and makers who are coming up with things like emulated Glock frames, printable Glock frames, or printable Glock style magazines, and even an increasing number of designs that are actually novel designs. They're not only just emulating commercial or conventional products, they're actually engineering new types of designs that are tailored to have the best kind of performance or meet certain kinds of consumer, requirements that the developers have in mind, by using only those consumer grade tools and only consumer grade plastics. So, nowadays, you can print Glock frames, you can print certain kinds of springs, you can print magazines, you can print all kinds of accessories and things like that. And so that space has been expanding over time.
And would you say the home printed Glock frame is as sturdy or as good as what?
No.
No.
Generally, no, but it is functional, and some of these plastic frames are proven to thousands of rounds. Now, if you compare in terms of, amortization, return on investment, increasingly you can make the argument that somebody 3D printing something like a Glock frame to make a functional, Glock emulation, that may only last, 1,000 rounds or 2,000 rounds or whatever, which is, nothing like a commercially manufactured Glock in terms of reliability, obviously, or durability. But you can print that for a few bucks, right? So the amortization, the value of being able to print something that's cheap, if it reaches a certain level of reliability, if it's not going to blow up in your hand immediately or fall apart within 50 rounds, then the cost of 3D printing some of these components has gotten approachable enough that it still makes sense as a product.
Well, now let's talk about the reliability and the not blowing up in your hand, which most consumers consider to be a very critical part for any firearm they'd want.
Maybe a minor objective.
Yes. So if you did want to make something like this for yourself as a hobbyist, first of all, you mentioned before that you wouldn't want to make the barrel out of, you'd want to, even if you're making it at home, you'd want to make the barrel out of metal on your computer numeric controlled lathe or whatever. What parts, as a practical matter of a firearm, still need to be metal?
Okay. Well, there are not very good firearms, in fact, pretty junky firearms that have been built, which are almost all plastic. It's increasingly possible to build firearms that would be all plastic, but the performance is generally extremely limited. There's also, of course, from the detectability side, which we can talk about in a few minutes if you like. There's also the fact that, all plastic ammunition, all synthetic ammunition does not really exist yet. So in terms of detectability, that's a kind of different issue. In all plastic, you can produce things like repeating revolvers. The earlier versions of these were mostly, 22s or rimfire, relatively low pressure ammunition to deal with the fact that the cheapest consumer grade plastics did not hold up well to the kind of pressures you're going to have modern ammunition and modern firearms. Increasingly, if you can do things like printable frames, printable handgun frames that emulate a commercial product, if you stick metal slides and metal innards on that, it's going to perform almost as well as a commercial item. There are also kind of tailor-made items that have been designed and engineered by people in the open source space that are, like I said, kind of novel designs. A lot of their kind of project is to try to come up with ways to engineer firearms that are closing the gap in terms of what DIYers can do to emulate a modern industry product, and do that with commercial off-the-shelf components and printed components that you use the printer to customize any kind of other thing that is not commercial off the shelf. So it's unusual to see full plastic firearms that are any good at all at this point still, but there are people trying to sort of innovate in that space without necessarily running across the UFA, the Undetectable Firearms Act. But all plastic stuff still is somewhat limited, and to make the good versions of an all plastic firearm really does require a great deal of skill. And it kind of begs the question of, why do you want to do that when you can make a much better gun if you just put in some metal components?
So let's talk about the Undetectable Firearms Act. Give the viewers some background on that.
Yeah. So in the 1980s, there was some concern, particularly centered around Glock and Glock's kind of innovations in terms of materials they were using. They were introducing polymer frames, which are corrosion resistant and durable and so on. And the widespread incorporation of plastics in conventional firearms was still kind of a novel new thing in the late 70s, early 80s. There were some movies and TV shows that talked about, mostly incorrectly, talked about, Glocks being the new plastic gun. It's not detectable and so on. That was never really true. But nevertheless, you can understand some of the concern that came out of that. So lawmakers very quickly passed the Undetectable Firearms Act, which mandates that a certain amount of metal has to be included, a detectable amount of metal has to be included in firearms, regardless of if the primary material of the firearm is plastic or synthetic.
Right, and I think it's approximately 4 ounces.
Yeah, I think that's about right. I can't remember.
And it has to have a profile that, in essence, looks like a small pistol. So,
right, that's another aspect of this.
Right,
is that the extended language of the UFA. It's not just that you have to have some metal in there, a little bit of metal. It's also that they have the security exemplar that is supposed to be sort of the benchmark for detectability, where you aren't supposed to design firearms, even if it has the right amount of metal in it. It's not supposed to necessarily look so unlike a conventional firearm that it wouldn't be detectable or something like that.
Right. So now, if you make your firearm at home, you have to, and let's say you just want to go all plastic. Pursuant to the Undetectable Firearms Act, I believe 18 U.S. Code Section 922P, you have to put that firearms exemplar in there of the 4.7 ounces of metal in the shape of a gun. Right. So that it's lawful to make an all plastic gun, except then at least the final steps to comply with U.S. law, you got to insert the firearms exemplar in there.
Well, you've got to
design it around that.
You've got to ensure that your design, in order to not run afoul of the UFA, even if you're designing something that's entirely functional just in plastic, you still, for those legal reasons under the UFA, you still need to add that detectable amount of metal to make it detectable in a metal detector.
Now let's talk about these scenarios from the bad guy's point of view. Somebody is a terrorist and wants to kill a politician in a high security situation, so he can violate the federal law, but you can print a all plastic gun,
Mhm.
And presumably, since he's going to use it to commit some terrorist act, he may not be too worried about the gun's durability because, by the time he's fired a few rounds, he's probably going to be dead anyway, killed by local security. So what's to stop that kind of scenario from happening?
It's more or less honor system in terms of, the DIYers that have been most active in the space come up with various kinds of plastic designs. In order to make the designs legal and comply with the UFA, they're including as part of the design or part of the instructions and schematics, small plates of metal that comply with the UFA and make it detectable in a metal detector. It's if you can gunsmith, if you can build guns out of metal, that means you can build machine guns out of metal. If you can build guns out of plastic, that means you can build all plastic firearms. They won't be very good, but they will be functional. So it's really the integrity of the builders and the positivity of the culture of people around it and their desire to comply with law and respect the law that really holds anybody to this.
Sure, and the American gunsmithing and DIY culture for hundreds of years has been a very honorable and positive and constructive culture, but surely there must be some people around the world who are not honorable and they're interested in Al-Qaeda type terrorism or whatever for some cause. Why aren't they already building plastic guns and using them to get past metal detectors?
Yeah, I think, and there's some speculation around this because we're still early in the trajectory of the technology and so on. But I think for the most part, the reason it hasn't been widely adopted by terrorists, all plastic firearms, have not been widely adopted by terrorists is because they're not very practical. To make one that's going to perform even decently, it requires a little bit more technical skill, a little bit more of a learning curve. To be able to make a product that you're going to trust to function. And even then, it's pretty limited in capability as compared to, any kind of conventional firearm that, let's say, if you're a bad actor, if you're a malicious actor, and I address this a little bit in the book in a chapter about detectability. If you're a bad actor and you want to engage in some kind of, clearly malicious attack, for some limited application, like an assassination where you only get one or two shots off and then it's all over, theoretically, there are ways to design and build an all-plastic firearm that might accomplish that goal. But when it comes to, an indiscriminate attack, the kind of outrages that, people normally think of when they think about terrorism or active shootings and things like that, the truth is, conventional firearms are still a completely, viable alternative to that. And, if you can break into 5 cars and get one free conventional firearm out of that, right? If you can burgle a few houses and get conventional firearms for free that are not going to be traced to you out of that, then, logistically speaking, and in terms of the barriers to entry, it's still a lot easier to get a gun illegally, a conventional gun illegally, than it is to build them from scratch. For things like more sophisticated terrorist organizations, violent organizations, drug trafficking organizations, they've already got supply and logistics chains. They engage in weapons trafficking themselves. So, there has been experimentation with additive tools and digital fabrication to customize and build components and things among some of those actors. But when it comes down to it, if you've got, more than a few people working for you and you've got money and you've got bad intent, it's still pretty easy to supply and source conventional firearms if you want them.
Is that true globally? I think of places like Japan or even Australia, both of which you've studied, where guns are certainly scarcer than here, and especially in Japan, quite scarce in they exist in the hands of law-abiding civilians, but not in large numbers. Has illicit plastic manufacture been more popular there?
It has happened anecdotally. I don't think there's much data as of yet on how popularized any of that's become in the underworld. But there are definitely anecdotal reports. Yakuza using printed firearms and other DIY, metal firearms that are expediently made out of, commonly available materials.
The Yakuza being the Japanese organized crime.
Yes. Outlaw, motorcycle clubs in Australia and Europe. And, there's been some interest among, say, white nationalist or white supremacist types or, tribalist sort of, garbage purveyors around the world. But when it comes to, any kind of real organized crime organization, syndicate, anybody who's got, their tendrils into domestic and international smuggling is already probably pretty well able to get firearms illegally. It's just a question of cost and how much risk you're willing to get your goons to accept in order to take the risk of trying to source and procure, right? So it comes down to it. A lot of organizations are already trafficking weapons, regardless.
Okay, let's talk some more about the possibility of regulations. Well, you talked about how the paradigm in the United States and sort of globally has been on the supply side of all the legitimate manufacturers. They have big factories. It's not exactly secret. They sell in a supply chain, and of course, Cabela's is going to obey the laws and fill out all the proper forms. Does this do what you're saying? And as we talked about, people have been making guns at home for hundreds of years, but so far the ability to make a gun at home really hasn't seemed to have much effect on the efficacy of our supply side regulatory system. Do you see that changing?
And there's increased discussion about that issue, and I think it is already having some impacts in those terms. ATF said, I think last year or 2 years ago, they claimed that an increased proportion of the firearms they're catching in crimes in California have not been serialized or have not been traceable based on serial numbers and things like that. You can try to sort of extrapolate some general trend lines in those terms. Certainly, there has been some adoption among the sort of criminal class in the United States and in other countries as well. I'm not certain that the regulatory ecosystem that we have for this is well equipped to deal with this kind of innovation, and that there are more and more people kind of talking about, does this fundamental kind of innovation, this development, this phenomenon of expanding capabilities in DIY or home gun making, does that force us over time to sort of reframe the entire discussion about how guns are even governed and regulated?
Well, elaborate on that. Some people, Cody Wilson, who's a famous distributor of printers that are well adapted for 3D guns and also of open source code for gun designs, he says this thing means it's the end of gun control. And in essence, everybody's going to buy one of these printers, and you learn how to push a few buttons and do a little typing on your computer, and boom, you got your new AR or your pistol or whatever. Is he? Do you think he's accurate about this?
Well, I guess I would paraphrase or quote someone else who's actually involved in the firearms and technology and sort of punditry space, John Stokes, who's worked with Ars Technica and has done a lot of firearms reviewing and has followed this space as well. I spoke with him, in the process of doing background research for the book, and he said something that stuck with me. He said, Cody wasn't wrong, he was just really early, which is another kind of wrong. And so if you ask me, is that capability going to be available, in 100 years? Are people going to be able to make, basically any kind of sophisticated physical item that they want, including firearms? I would say, anything can happen. It's very difficult to kind of project with the rate of change and accelerating innovation that we do see. It's also difficult to project what kind of pushback we're going to see and the efficacy of that pushback from the regulatory side and from the mainstream tech sector as well. But the current trajectory is that the cat is already, more than halfway out of the bag, I think, in terms of there are already designs and capabilities out there that people are innovating on that at this point, most of the regulatory proposals that are being made even at this point still would be, I think, behind the game in terms of being able to really stop people who are motivated to do it.
Well, so let's talk about some possible regulations there.
Mm-hmm.
Why not have licensing for the ownership of a 3D printer to start with?
Right. Well, that has, I don't think, been really seriously proposed, in part just because 3D printers are and additive tools and digital fabrication tools. They're increasingly open source, which is to say, you can buy them used, you can buy components and build them, you can get software, open source software architectures to build and program those kind of devices yourself. And people increasingly do that. And on top of that, the vast majority of people who work with 3D printing, either at the workplace or small business or in their home, are probably not even interested in making guns to begin with. And so there would be some pushback, I think, from some of the 3D printing industry, saying that, well, we don't necessarily want to be associated with, a scary kind of phenomenon, and this phenomenon is sometimes unsettling in terms of some of its implications. And once in a while, you do see people, take malicious actions with firearms that are homemade or DIY. And increasingly, as a trend, we do, I think, see that in some criminal adoptions, particularly in states where theoretically there are more regulations at the retail level. But as these things sort of develop over time, it's a real question, I think, that's going to define the technology space and the ethics and law going forward of Second Amendment and First Amendment, for that matter, because we're going to reach a point probably within a few years, maybe 10, certainly within 20, where if technology continues along its current path, it's going to be fairly easy to make firearms, particularly if you're motivated to do it or you want to do it for an illegal purpose. At that point, the kind of laws we have now are going to be, I think, even less applicable to the firearm space than currently.
Well, so from the point of view of people who want gun control, isn't it time to start enacting as many possible laws right now? Even if the cat's halfway out of the bag, maybe you can still grab the tail or the hind leg.
Mm-hmm. Well, and I think most likely that'll happen. And I think there's going to be probably a push for it. In the book, there's always a several month, if not year, delay from the last kind of update of the content you did. I think given the sort of political winds and some of the ways the issue's been covered and talked about within the sort of pundit class on it, I think there's likely to be pushback, and there's going to be more of an attempt, I think, to impose a little bit more order on this very open, highly innovative space. Now, how that hashes out in reality, I don't know, and I don't think anybody knows. But I've heard from people who are very innovative in this space, people who are kind of considered to be leaders in this space in terms of designing new kind of products that you can make with consumer grade tools and coming up with some very kind of clever gun hacks. At this point, I think it's reached a kind of movement level, primarily within the United States, but also there's increasing interest from makers in other countries too, where they would resist. There's legal pushback, there's technological pushback. But even if you implemented, I think, all the laws that I'm aware of that have been proposed to govern this space, I think those laws would be difficult to enforce, and hard pressed to really stop motivated actors from doing it.
Well, what about restrictions on software distribution? The computer-assisted design, CAD files for how to make a gun.
Mm-hmm. Well, that hits at, I think, one of the really fundamental legal and ethical questions about as technology expands what you can make and how you can make it, it becomes much more information driven, right? And so the ability to make firearms and the ability to customize and design components and all these sort of things, the ability to share ideas and innovate and build on other people's designs, that is all more information driven than tool driven. And so the ability to share files and share schematics, the ability to share information about how you build things, is really starting to drive it as more of a kind of sub-information economy or an information-driven phenomenon. So you get to this point where if you say, well, it's not very realistic to regulate the tools, and it's not very realistic necessarily to regulate the materials, then perhaps, our one real leverage point to try to regulate this effectively and stop motivated people from trying to do it is to actually regulate the information itself. And that opens up a whole other Pandora's box legally and ethically and socioculturally.
Well, what's so hard about saying it's illegal to share a file, or more to the point, it's illegal for a web server to host a file that can be downloaded about how to make a firearm?
Well, I would say from a technical standpoint, the hardest thing about that is implementation in a way that's actually going to prevent a motivated person from accessing the information. So there are many kind of alternatives available, and there's been a lot of flexibility, you could say, about trying to shut down certain kinds of speech or information on the internet. There's been controversy about online fora that have a lot of toxic speech on it, a lot of mean-spirited speech like 4chan and people using those kind of fora to put out terrorist communications or white supremacist manifestos and things like that. But when you shut down those sites, they always pop up again. Or at least that has been how it is historically so far. If you have any kind of gray zone of uncontrolled, unsurveilled space within the technology sector and within the internet, then people are going to find ways to trade information. And so by saying we'll make it illegal, fundamentally illegal, to put any kind of firearm file online, that's actually been said before by the courts, and the firearm file stayed online. So there are a bunch of people now that are part of this kind of phenomenon that they're almost motivated to try to preserve this knowledge and continue innovating in this space, regardless of what kind of laws anybody wants to pass.
So what's your expectation of where we'll be 5 or 10 or 20 years from now?
Well, I think within the next couple years, we're going to see an expansion of regulatory effort to try to impose something akin to a supply side control, right? And I think that could be a red herring in terms of the effectiveness of any kind of public safety objective that you have behind the laws, in the sense that you can maybe chill the wider popularization of this phenomenon. People, CNC milling and home printing firearms. You can try and chill the popularization of people finishing 80% components and things like that. You could go after commercial suppliers that sell precursor components, but then you get into this question of at what point are you defining a piece of metal as a firearm part, right? If you take it down to 70% completion before you sell it, or take it down to 50% completion before you sell it, So you get into all these definitional problems of when is a firearm, and when is commerce. And so there's a lot of gray area there. So I think within the next couple of years, we're going to see considerable regulatory pushback to try to impose what is really just a slightly updated version of conventional gun control, trying to apply some sort of, retail style top-down control to this phenomenon. But I'm skeptical that any of that's going to be very effective. And then within a few years after that, I think it will be more and more clear to observers on various sides of our really, toxic, polarized gun debate that we have. It'll be clearer and clearer that your primary sort of options are to really clamp down on information and internet freedom, or to allow this to sort of continue developing and then find a whole other way to frame the conversation about how do we manage guns at ground level and reduce demand and reduce actual violent activity in other ways besides trying to control the distribution of guns in a country that's already completely full of guns.
All right. Well, I want to, as we wrap up, show the viewers your book again, Ghost Guns. Buy it. It's great. Read it. But for people who want more information, where can they get some more information and your latest writings?
Oh, well, I'm kind of redoing my website, so I don't know if I should mention that here, but yeah, just Prager ABC Clio. It's available on Amazon, and I'm working on updates. Already thinking about what would go into a re-edition to try to keep up with the innovation that's going on in this space, and thinking about some new publications as well to talk about some of the other kind of issues that have to do with if you can manufacture a wider spectrum of things from wider locations and so on, what kind of implication does that have for traditional regulation and security?
Sure. And do you have a faculty page at Massachusetts Maritime?
Actually, I'm not sure.
Okay.
I'm not sure what the deal is with that. It's findable, but it's not really easily searched on Google. You'd have to go into the faculty directory to get in there. So I don't know if I want to.
All right. So
put that out.
So for the time being, folks, you just got to buy this book. But we will have Mark Tallman back on future episodes and talk about new developments. And when his new revised website gets going, we'll give you information on that as well. So, Professor Tallman, thank you very much for joining us. I think this is a very interesting and enlightening conversation.
Yeah, my pleasure. I thought it was really interesting, and take care.
Okay, thanks. Bye-bye. Thank you for watching this episode of Kopel's Law and Liberty News. If you'd like more content from Independence Institute Television, check out these videos here. And be sure to click the subscribe button so that you'll be notified when we release a new video.